So namaskar, adab, sat shri akal, kaisa kahe, 𝐂𝐤𝐬, hello and welcome in GATE Wallah. So student, this is your next lecture of the subject vibration, which we are discussing for aerospace branch. In this lecture today we are going to discuss continuous vibration. Okay, so first we will discuss its introduction, then we will discuss continuous vibration for various cases, like in continuous vibration we will discuss transverse vibration in string, longitudinal vibration in bar, torsional vibration in shaft, and transverse vibration in beam. Okay, so this particular topic now, if you see the syllabus of GATE Aerospace na, in it is mentioned in special topics. Okay, so it is not the part of main syllabus, it is mentioned in special topics. Okay, now first of all we will discuss what is the meaning of continuous vibration. See, suppose this is the beam. Right now suppose this beam is massless. Okay, now in this beam one point mass is attached. Okay, and suppose transverse vibration is occurring in this beam. So if 1 point mass is attached now, then degree of freedom of vibration of this system will be 1. Okay, and this case we have already discussed. This case we have discussed yesterday, or I think day before yesterday. Okay, similarly in this beam, if this beam is massless, but in this beam if 2 point mass is attached now, then degree of freedom of this system will be 2. Now, what is the meaning of continuous vibration? Continuous vibration means in this beam, separately no point mass is attached. But right now this beam is having inertia or mass. It is not massless. And if it is having inertia, it will be distributed mass. And if it is distributed mass, can I say the mass of this beam will be distributed in infinite point. Okay. So you can consider like it is having infinite masses. Okay. So if 1 point mass is attached, degree of freedom 1, it is 2. Its degree of freedom is infinite. And when for any vibratory system degree of freedom it is infinite, then vibration of that structure is known as continuous vibration. So continuous vibration means the mass of this beam is given, which is distributed mass. So whatever vibration is occurring in this beam, it will have infinite degree. Infinite degree of freedom means it will have infinite frequency. Okay, then this vibration is known as continuous vibration. Now in continuous vibration, mainly we will discuss 4 cases. One is transverse vibration of a string or cable, longitudinal vibration of bar, torsional vibration of shaft, and transverse vibration of in beam, or you simply I can say vibration in beam. But if you see now, I have written this first 3 topic in white color. Okay, because now in first 3 topic, if you understood the first case, means you understood this also, you understood this also. Only there will be some analogy, you have to remember that analogy. Okay, and then we will discuss this vibration of beam separately. Okay, yes. So first I am discussing this first 3 case. So what I am doing, first I am discussing transverse vibration of a string or cable. But if you understood transverse vibration of a string or cable now, you will understand longitudinal vibration of bar also. You will understand torsional vibration of shaft also. Now see, here what I am doing, I am considering this is a string. The length of this string is L. Okay, the length of this string is L. Okay, and suppose this in string is having some mass. So suppose mass per unit length. M is not total mass, it is mass per unit length of the string. Okay, now if I will disturb this string from its mean position and after that release, it will vibrate. Okay, but here what will be the frequency of that vibration? That will depend upon the initial displacement which we are providing, and based on that it will have some frequency, because here infinite frequency are possible. Why sir? Because it is having infinite degree of freedom. How I will explain? See here now, how infinite. See here now, just suppose right now both end of this string are pinned, or you can say refer as fixed connection. Okay, I am not saying always both end it will be pinned. It might be possible in some case it is pinned or fixed, it is free. Both are pinned or both are pinned. Both are free. But just for understanding, suppose both end are pinned. Okay, then you can imagine one type of vibration which can occur in this system is now like this. See, it is going like this, then above as like this. This is one way of vibration. Another, it can, in this system, vibration can occur like this. Okay. Next, vibration can occur like this. I will explain with equations also. Yes. Okay. Okay. Similarly, you can make various mode of vibration. Okay. So here vibration can occur in infinite way. Okay. Just for understanding, suppose during vibration, I am drawing a diagram after displacement. But I am not saying always displacement is like this. It can be like this also. It can be like this also. Just for understanding, I am taking any diagram. Okay. Now, here now, suppose that during vibration, the displacement at any distance, suppose I am taking any distance x, is y. But this actually, y will depend upon two parameters. First of all, it is the displacement at any distance x. But during vibration, displacement at distance x will also change with time. So actually, y will be the function of two parameter, x and time. Y will be the function of two parameter, x and time. Like suppose during vibration, what is the displacement at a distance x equal to L by 2 at time equal to 0, means initial, at time equal to t second, at time equal to 3 second. Similarly, what is the displacement at a distance x equal to L by 3 at t equal to 0, at t equal to 2 second. So actually here y is the function of two parameter, one is x, second one is time. Definitely during vibration, displacement will depend upon time. But here along with this, it is depending upon this space coordinate also, which is x. Okay. And since here two variable is coming now, so here if you derive the governing equation, so here you will get partial differential equation because there here two variable are coming. But here now we will not go on derivation because here derivation is not important. See, during transverse vibration of a string or cable if you write the governing equation of vibration, first of all, it is a partial differential equation, and that partial differential equation is known as wave equation. Because if you see now, vibration also, it is like a wave. Like when vibration is occurring like this, it is like a wave. Okay, when vibration is occurring like this, so it is like a wave. So here whatever finest governing equation of vibration is coming now, that is wave equation. Okay, and you have to remember that differential equation. So it is a wave equation. Okay. Now one of the standard form of wave equation is del square y by del x square. Why I am writing in terms of del? Because it is a partial differential equation because two parameter is coming now. Partial differentiation means it is the differentiation of equation of y with respect to x two time, but during that differentiation we are assuming time is constant. This is the meaning of del. This is equal to 1 upon c square del square y by del t square. So it is the differentiation of y with respect to time two times, and during that differentiation we are assuming x is constant. Okay, so this is the standard form of wave equation. Now here I have written this for transverse vibration of a string, but whatever equation I have written, it is valid for this case also, this case also, this case also. Only analogy you need to understand. Okay. Now what is C here? C is constant. Okay. The formula to calculate this constant C in case of transverse vibration of a string, it is for string na, root over T upon M. Okay. What is M? I have already written here. It is mass per unit length. What is T? It is tension in the string. In the string. Okay, generally examiner will give the value of C. So this is 1D wave equation. Okay, it is nothing but double order linear differential equation. It is also known as homogeneous equation. Okay, so this is partial differential equation, which is 1D wave equation. Okay, now when you will find its solution, in solution also you will get the solution will come in terms of variable x also, in terms of variable time also, because here y is the function of x and time. So if you will solve this equation, again I am not going on derivation, that you have to remember. First of all, the governing equation is del square y by del x square equal to 1 upon c square del square y by del t square. Okay, at last I will make the summary, only you will you need to remember the summary. Okay, now here when you will solve this equation now, okay, here y will come as a function of x and as a function of time. Okay, like suppose the expression of y which is coming in as a function of x is this part, the term which is coming as a function of time is this part. Just for understanding, I am writing like this. Now if you solve this equation now, ultimately the equation of y will come like this. It is a sine omega by c x plus b cos omega by c x into capital C sine. This capital C is not this C, na? It is a constant C. See, if you are solving differential equation, na, here 4 arbitrary constant will come. Okay, so here A, capital B, capital C, capital D are arbitrary constant. They will depend upon boundary condition. A sine omega t plus capital D cos omega t. Okay, this you have to remember. Okay, yes. So this is 1D wave equation, and for transverse vibration with string, this is the solution. If you read one time, na, you will understand. See, here na simple harmonic term is coming in terms of time. C sine omega t plus D cos omega t. Here how you can remember, na? Here instead of with x, omega by cx is coming. Why? This is coming after derivation, after solving this equation. But we are not going in the derivation of this solution. Okay. Yes. Now after that, now whatever case I will discuss, I will properly derive. But whatever concept I discussed till this point, that you have to remember. Okay. Now if I will ask what is the frequency of this vibration. So whenever you are calculating frequency, na, in the harmonic function which is coming as a function of time, because frequency means time dependent, na? In that equation, see what is the coefficient of time. Here coefficient of time is omega. So here the natural frequency of this system is omega. But how will calculate the value of omega? For that, now we need to know boundary conditions some. Okay. So here actually now, if you want to completely solve this equation, at least you require 4 information, because 4 arbitrary constant are coming. 2 information you require related to space coordinate. X is space coordinate, na? Now information which we are knowing as per space coordinate, that information is known as boundary condition. And generally that depends upon the end condition. And 2 information I required as a time function. Okay, so generally for that, na, examiner provide, if examiner asking complete solution, na, so for that examiner will provide initial condition. Initial condition means what are the value of y, or what is the value of velocity as time equal to 0. So with time coordinate, whatever information I am providing, if I am providing that information for time equal to 0, that is known as initial condition. So if you want to completely solve this equation, you require 2 boundary condition. When I am saying boundary condition means information related to space coordinate, and we require 2 initial condition means information at time equal to 0. Okay. Now for boundary condition generally depends upon and conditions, and we have to study 3 cases. I am discussing one by one. First I am discussing case 1. And in all the cases, question which will come is regarding the calculation of natural frequency. Examiner asks calculate what will be the natural frequency. So in case 1, I am taking fixed connection. Means both end of the string is fixed, or you examiner can also refer as pin. Okay. Here when I am saying fixed, fixed means displacement cannot occur. It is not a beam. You are thinking that it should be like fixed support. This is different, this is different. It is not a beam. So in a string, whether examiner is saying fixed or pin, both are same thing. Now here you can easily tell what will be the boundary condition. Right, I am taking x from this location. So can I say, since here both end are fixed, so during vibration, whether displacement of this point and displacement of this point will be 0. So can I say here one boundary condition is at x equal to 0, y equal to 0, because at fixed end displacement will be 0. Similarly, can I say here at x equal to L also y will be 0. So these are the 2 boundary conditions. And by using this, we'll find natural frequency. So I'm using this equation. Okay. So what I'm doing, suppose this is equation 1, or I'm writing this equation here, a sine omega by cx plus B cos omega by Cx, capital C sin omega d plus capital D cos omega t. Now what I am doing? First I am putting x equal to 0, y equal to 0. If you put it is 0, now x equal to 0, so it will be sin 0. So this part will be 0. And here cos 0 will come. Cos 0 is 1, so here B will come. C sin omega d plus capital D cos omega d. Now when this 0 is possible, when B is 0. Okay. Because this term will always not be 0, then how vibration will occur? So can I say here the value of B is 0? So I got the value of constant B. This is only for understanding. Now only understand. You need not to mug anything here. Okay. Now I will put this equation, putting this value of B equal to 0 in equation 1. So equation of Y will become A sin omega by Cx. Now C sin omega d plus capital D cos omega t. Yes. Now I am putting this second boundary condition. What I am putting? Put x equal to L and y equal to 0. So this part is 0. A sin omega L by C. X equal to L, na? Yes. C sin omega d plus D cos omega t. Here I am going to make any important conclusion. Now when this will be 0? Now see, it will be 0 when this part is 0. Reason? Because A cannot be 0. You will say, sir, it will be 0 when A is also 0. But if both A and B are 0, means Y is always 0. And Y is always 0 means no vibration is occurring. Okay. But right now, since vibration is occurring, so they definitely always Y will not be 0. So that's why A cannot be 0. So if A cannot 0, so this 0 is only possible when sin omega L by C is 0. This is the most important conclusion. Okay. And that will remember, but at last now after entire discussion, I will make a table and only you have to remember the table. Okay. Okay. And that table is valid only with some analogy for transverse vibration of a string also, longitudinal vibration of bar also, and torsional vibration of shaft also. So see, this equation is known as frequency equation because through this equation you can calculate the value of omega. So that's why this equation is known as frequency equation. Means simply you can remember in string for fixed connection, the frequency equation to calculate natural frequency is sin omega L by C equate with 0. Now when sin will be 0, if sin theta is 0, so sin theta is 0 when theta is n pi. So here when it will be 0, when omega L by C will be n pi. Okay. And here n is starting from 1, 2, 3, 4, 5. I am writing 0 also, but I will eliminate this. When it will be 0, when omega L by C is equal to n pi. N is 0, 1, 2, 3. Sin 0 is 0. Sin pi is 0. Sin 2 pi is 0. Sin 3 pi is 0. 4 pi like this. Okay. But here now, in fixed connection, n equal to 0 is coming, but I am not writing this. Reason, when n is equal to 0, it means, what is the meaning of this? When n is equal to 0, means omega L by C is 0, means omega is 0. Okay. And omega is 0 means it is vibrating with 0 frequency. But that is not practically possible here. Okay, see, it is vibrating with 0 frequency is possible now when both end are free. If both end are free now, one vibration which can occur now, it can occur like this. See, a string is not deforming. It is just moving up and down like this. Up and down. But it is possible when both end are free. But if at least one end is fixed, here so both end is fixed. In that case, 0 natural frequency is not practically possible. So if you write practical possible value now, so since omega 0 is not practically possible, that's why practical value of n is starting here from 1. So n is starting 1, 2, 3, 4, 5. Okay. Yes. So this is the, if you remember this, you can easily write this omega L by C equal to n pi. Okay. And n is starting, just remember this from 1. Okay. Yes. If you remembering this now, this entire calculation you can do. Now here if I will calculate first natural frequency, means by putting n equal to 1, omega will come. if you know the equation of omega L by C is n pi, you can write the equation of omega also. N pi C by L. But this you need not to remember. After this, you can easily write this. Okay. Now, if I will put n equal to 1, I will get first non-zero frequency or first frequency, which is coming omega 1 omega C by L. Okay. This frequency, see, in infinite vibration case or in continuous vibration case, whatever first non-zero frequency is coming, okay, that is known as fundamental frequency or fundamental mode. So if examiner asking in fixed connection in transverse vibration of a string, what is fundamental frequency? So the frequency which I am getting here by putting n equal to 1, because the first non-zero frequency is known as fundamental frequency. Okay, it is known as fundamental frequency. Okay, so sometime examiner can ask what is the fundamental frequency. Like if you put n equal to 2, it is known as second mode. N equal to 3, third mode. N equal to 1, that is first mode. But here first mode frequency is also known as frequency of fundamental mode or fundamental frequency. Again, frequency is coming in radian per second. Na? If examiner asking in hertz, you can do that conversion. If examiner asking time period, you can do that conversion. So summary is in transverse vibration of a string, for fixed connection, frequency equation to calculate natural frequency. Just remember this. After this, you can easily write. Here, zero frequency is not possible. That's why anyways start with 1. Okay, now by putting n equal to 1, whatever frequency is coming, that is known as fundamental frequency. Okay, but it is for fixed connection. Okay. Now I'll discuss these things for fixed free connection. Means one end of the string is fixed and other end is free. One end of the string is fixed and other end is fixed, free. Okay. Now here one more thing. In fixed connection the vibration which I was discussing earlier see, by putting n equal to 1, you will get frequency. But in n equal to 1, whatever vibration will occur it will be like this. Okay. Similarly, if you put n equal to 2 just for understanding I am explaining, the vibration which will occur in the string will be like this. You'll put n equal to 3, the vibration which will occur will be like this. Okay, so based on the which mode of vibration is occurring, that will decide how vibration occurs in this string. Okay. Now I am discussing this vibration in fixed free connection. Now in fixed free connection I am discussing this for any one mode. See, when vibration will occur it will occur like this. Okay, this is one mode. But what conclusion I want to make from here? See, it is obvious the end which is fixed, the displacement of that end will be 0. But what is the important conclusion for free end? So see, the end which is free, definitely at that end displacement can occur. But you can see the slope of that end is 0. So at free end, del y by del x will be 0 because slope means del y by del x. This is important. Now here suppose x I am taking from this fixed end, the length of the string is L. So can I say here what will be boundary condition here? Boundary condition is important. At x sometime in 1 mark question can come in which examiner will ask just boundary condition. For fixed at x equal to 0, y 0, at x equal to L, y equal to 0. For fixed free, if I am taking x from that location where it is fixed. So can I say at x equal to 0, y will be 0. Now next, at x equal to L, y is not 0. Del y by del x is 0. Okay. So these are the boundary condition. Okay. Now just using this. Okay. Now we know the equation of y is like this. A sine omega by cx plus b cos omega by cx, then capital C sine omega t plus capital D cos omega t. Now equation 1. Now put x equal to 0, y equal to 0. It will be like this, y equal to 0, x equal to 0, this part is 0, cos 0 is 1, so it will be b in bracket c sine omega t plus capital D cos omega t. So b will be 0. Okay. Now I am putting b equal to 0 in equation 1. So now final equation of y is coming like this, a sine omega cx capital C sine omega d capital D cos omega t. Now other boundary condition we know related to del y by del x. So first I am, suppose this is equation 2. Now first I am finding the expression of del y by del x. So what we'll do, differentiate this equation partially with respect to x. Partially means apart from x other variable, like we'll consider time as constant, because this is the partial differentiation of y with respect to x. So see, differentiation of sine will be cos, so it is cos omega by cx. Now I will multiply separately with omega by c, so it will become a omega by c. This will come as it is c sine omega t plus d cos omega t. Okay. Now here, this is the equation of del y by del x. Now in this equation, I am put x equal to L and del y by del x equal to 0. Okay. So del y by del x 0 means this part is 0. Okay. Now x equal to L, so it will be a omega by c cos omega by cx, and instead of x we are putting L. C sine omega t plus d cos omega t. Okay. Now here when this will be 0, so again a cannot be 0 na, because if a is also 0, always y will be 0. That is not possible. So here it will be 0 when this part is 0. So this is the frequency. In fixed connection, frequency equation is coming in terms of sine omega L by c 0. But for fixed free connection, that is the final summary, frequency equation will come in terms of cos omega L by c is 0. Cos omega L by c 0. Now when cos theta is 0 na, when cos theta is 0, when theta is 2n plus 1 pi into pi by 2, and here n is starting from 0. We'll put n equal to 0, it will be pi by 2, cos pi by 2 0. N equal to 1, it will be 3 pi by 2, cos 3 pi by 2 is also 0. So when cos theta is 0, when theta means here omega L by c is 2n plus 1 pi by 2. That's it. Okay. Okay, and means omega will be, but you need not to remember the equation of omega. After this, you can easily write this. Then you can do shifting, na? It will be 2n plus 1 pi c by 12. But here n is starting from 0. So 0, 1, 2, 3, 4. Why, sir? Miss in zero frequency, no, zero frequency is not possible. But here if you put n equal to 0, it is not coming 0. Now you can check, if you put n equal to 0, it is coming pi c by 12. Pi c by 12. Yes. So that's why n is starting from 0. Okay. Now here again, if you calculate frequency of fundamental mode, frequency of fundamental mode means first non-zero frequency. So here if I will put n equal to 0, I am getting non-zero value. So here frequency of fundamental mode I will get by putting n equal to 0. Put n equal to 0. Okay. First frequency of fundamental mode will come pi c by 12. So it is natural frequency of fundamental mode. Okay. Yes. Clear? Last, the free connection. Both end are free. Means here at x equal to 0 also, del y by del x 0 because it is free. At x equal to L also, del y by del x is 0. Okay. Now again we'll solve. So see, here equation of y is like this, na, a sine omega by cx plus b cos omega by cx, c sine omega t plus d cos omega t. Now both boundary condition I know related. Suppose this is equation 1 related to del y by del x, so I am finding the expression of del y by del x. Now if we differentiate this, it will be a omega by c cos omega by cx. Here also omega by c will come outside, and differentiation of cos is minus sine. So it will be minus sine omega by cx. Okay. So it will be a omega by c cos omega by cx minus b omega by c sine omega by cx into c sine omega t plus d cos omega t. This is equation 2. Now I am using first putting x, put x equal to 0 and del y by del x equal to 0. It will be del y by del x 0. Now here we'll put x equal to 0, cos 0 is 1. So it will be a omega by c. Here we'll put x equal to 0, sine 0 is 0, so this part will be 0. So into c sine omega t plus d cos omega t. So here a is coming equal to 0. Okay, yes. Now I am putting a equal to 0 in equation 2 na. First I am putting in equation 2. So equation of del y by del x will become equal to, so this part will be 0, minus b omega by c sine omega x by c sine omega t plus d cos omega t. Now I am putting x equal to L and del y by del x equal to 0. So del y by del x 0 minus b omega by c sine omega L by c sine omega t plus d cos omega t. Now definitely again here b will not be 0, because if both a and b are 0, always y will be 0. That is not practically possible. So here when this will be 0, when this part is 0. Okay. And this is nothing but when you are getting sine omega L by c equal to 0, it is frequency equation. Means if I will write frequency equation for fixed connection, frequency equation was sine omega L by c equal to 0. Okay. Means omega L by c n pi, n is starting from 1. For fixed free connection, frequency equation was coming in terms of cos omega L by c equal to 0. Means omega L by c is 2n plus 1 pi into pi by 2, n is starting from 1. Now for free connection, frequency equation is same as fixed connection. Means again it is coming in terms of sine omega L by c equal to 0. And sine omega L by c 0 means omega L by c equal to n pi. Means omega is equal to n pi c by L. Only difference is now, in this case, n will start from 0. In fixed connection also frequency equation was same. This equation is again coming same. But in that case, n was starting from 1, because by putting n equal to 0, it was coming 0. But 0 frequency in fixed connection was practically not possible. But here 0 frequency is practically possible. How? If we put n equal to 0 now, omega will come 0. In that case now, how vibration will occur? It's just string will move just up and down. It will not deform. It will just move up and down like this. And since it is not deforming now, this is known as rigid mode. Okay, rigid mode is only possible in this case. And rigid mode frequency is 0. Rigid mode frequency will always be 0. Okay. And here by putting n equal to 1 na, I will get frequency omega equal to n pi c by L, no, means pi c by L. Okay. But if I will ask na, in this case, what is frequency of fundamental mode? So frequency of fundamental mode means the first non-zero frequency, because here 0 is also possible, but it is not frequency of fundamental mode. So in this case, if examiner asking frequency of fundamental mode, that is again the frequency which I am getting by putting n equal to 1, because frequency of fundamental mode means first non-zero frequency. Now here if I am putting n equal to 0, I am getting 0. So that is not frequency of fundamental mode. Now if I am putting n equal to 1, I am getting non-zero. So if examiner asking frequency of fundamental mode, again it is coming by putting n equal to 1. Frequency of fundamental mode. But here rigid mode frequency is also can occur. So if examiner asking rigid mode frequency, that is 0. Okay. But here n will start from 0. But now frequency of fundamental mode means first non-zero frequency. So first non-zero frequency I am putting n equal to 1. So that is the frequency of fundamental mode. Okay. Okay, now I am writing the summary, and only you have to remember the summary, and this summary is for other cases also, means for longitudinal vibration of bar, for torsor vibration of shaft also. What is the summary? in a string na, first of all equation is wave equation, del y square y by del x square equal to 1 upon c square del square y by del t square. C is root t by m first of all. Yes. Now here if you want to write solution, that also you can write. Okay, capital A sin omega by cx plus capital B cos omega by cx, then capital C sin omega t plus capital D cos omega t. But important conclusion now I'm writing in table. You have to remember the frequency equation for three cases. One is fixed connection. Suppose I am taking x from here. So I am writing the boundary condition also, na, because sometimes examiner can ask boundary condition also. That is easy. At x equal to 0, y equal to 0, and I am taking length of string as L. At x equal to L also, y equal to 0. Now here I am writing frequency equation. Frequency equation is in terms of sin omega L by C equal to 0. So the frequency will be, okay, when sin theta is 0, when theta is n pi, so it is omega L by C equal to n pi. I am just writing this. Now you can do shifting, na. Omega will be n pi C by L. Okay. And here n is starting from 1. That's it. Because here 0 frequency is not possible, na? Yes. Now here if examiner asking frequency of fundamental mode, that is very easy. The first non-zero will get by putting n equal to 1, it will come pi C by L. So that you can do, na? Second was fixed free connection. Okay. Suppose I am taking x from this location. So right now at x equal to 0 it is fixed. So at x equal to 0 y is 0, and at x equal to L it is free del y by del x is 0. Here frequency equation is coming in terms of cos. So it is cos omega L by C 0. And when cos theta is 0, when theta means omega L by C is 2n plus 1 into pi by 2. Okay. Here n is starting from 0. Okay. Here if examiner asking frequency of fundamental, put n equal to 0, because by putting n equal to 0 I am getting non-zero value. Na? First non-zero frequency is frequency of fundamental mode. So here put n equal to 0, you are getting non-zero. It is pi C by 2n. Okay. That you can write. Na? Last, I am writing here itself because in same table you will get all data. Na? Fix. Oh, sorry. Free. Suppose I am taking x from this. So here x equal to 0, del y by del x 0. At x equal to L also, del y by del x is 0. Here frequency equation will come in terms of sin. Means sin omega L by C equal to 0. Okay. So here omega L by C will be equal to n pi. Means omega is n pi C by L. But here only difference is n is starting from 0. Na? If we put n equal to 0, frequency is coming 0. That is known as rigid mode frequencies. But here rigid mode is possible. But if examiner is asking fundamental frequency, that is again first non-zero frequency. So by putting n equal to 0, I am getting omega 0. So that is not frequency of fundamental mode. Now put n equal to 1. By putting n equal to 1, I will get non-zero frequency. So that will be pi C by L. So if examiner asking in this case, frequency of fundamental put, by putting n equal to 1, I am getting pi C by L. Here we are asking frequency of fundamental put n equal to 0 because it is coming non-zero. Frequency, so here it will come pi C by 2L. Here frequency of fundamental mode I will get by putting n equal to 0, which is pi C by L. This is C, na? Clear? So this is transverse vibration in string. After that, I will discuss transverse vibration in, longitudinal vibration in bar. So when you are discussing longitudinal vibration in bar, longitudinal vibration means in bar vibration is occurring like this. Okay. So again here vibration will be wave equation. Means solution will be same as the solution which we are getting in a string. Now here during vibration, suppose that axial displacement, because here displacement will occur in axial direction. Na? Axial displacement at a distance x at any time t is y. That is your representation. If I am denoting axial displacement again as y. Okay. So again here it will be wave equation, means del square y by del x square equal to 1 upon c square del square, same thing is repeating, del square y by del t square. Del square y by del t square. Here C is constant, only difference in the formula of C. In case of bar, the formula to calculate C is root over E by rho. What is E? E is Young modulus. Okay. And what is rho? Rho is density in kg per meter cube. Means mass density. Okay. Yes. Okay. Here again, the equation of y is like this, because same thing is coming as a sine omega cx plus b cos omega by cx t sine omega t plus d cos. Okay. Yes. Clear? Now I am not going in derivation. Same thing will repeat. Again, if it is fixed connection, so length is L, I am taking x from this location, means again boundary condition is same. Here I am writing boundary condition, x equal to 0, y equal to 0, x equal to L, y equal to 0. Frequency equation, same thing will repeat. Sine omega c by, omega L by C equal to 0, means formula to calculate frequency is, means omega L by C will be n pi, means omega is n pi C by L, and n is starting from 1, because here by putting n equal to 0 it will come 0, which is not practically possible. Second, fix free, like this. I am taking x from this, length is L. So at x equal to 0, y is 0. At x equal to L, del y by del x is 0. Frequency equation is cos omega L by C is 0. Means omega L by C will be 2n plus 1 pi by 2. Here n is starting from 0. You'll put n equal to 0, it is coming non-zero. So that is frequency of fundamental mode. Same thing is repeating. Next is free. Both end is free. At x equal to 0, del y by del x is 0 because it is free. X equal to L also, del y by del x is 0. Now here frequency equation is coming in terms of sine. Sine omega L by C is 0. Means omega L by C is n pi, but here n will start from 0. By putting n equal to 0, it is coming 0. That is frequency of rigid mode. Means if we are calculating frequency of fundamental mode, that is first non-zero frequency, which I will get by putting n equal to 1. Clear? Same thing. Okay. Next, if it is, not transverse, it is typing error, actually it is longitudinal vibration of bar. Longitudinal means vibration is occurring like this. Okay. Then torsional vibration in shaft. Torsional. This is suppose shaft. Okay. This vibration is occurring like this. Okay. During that vibration, twist will occur. So suppose angle of twist at a distance x, at any time I am representing as theta. So theta will be the function of x and time. Okay. Again here equation is wave equation, means variable, instead of variable y I am representing that as theta, because here twist is occurring. So del square theta by del x square is equal to 1 upon c square del square theta by del t square. And as per this equation, the formula to calculate C is, now only you have to remember the formula to calculate C. It is root over Gj by, I am writing I naught, whatever notation you want to take. Here what is Gj? Gj is torsional rigidity. In which G is modulus of rigidity and J is polar area moment of inertia. Like if cross section is circular of diameter d, the formula to calculate J is pi by 32 d to the power 4. Now what is here I naught? I naught is mass moment of inertia of shaft, but not total per unit length. It is mass moment of inertia of the shaft per unit length. They are analogous. See, if you see this now, here I written this as E root E by rho. But what I will do now, if I will multiply area above and below side. So above side root A will come. You need not to write this, but just for understanding I am writing. Below side it will be rho into area. Suppose rho into area I am writing M, because what is rho into area? Can I say rho into area, which I am representing as M, is mass per unit length? See, rho AL will be total mass. So rho into A will be mass per unit length. Na? So M equal to rho into A is mass per unit length. It's not total mass, mass per unit length. So see, what is EA? It is axial rigidity. And below side mass per unit length will come. So in torsional vibration, instead of axial rigidity, torsional rigidity will come. And instead of mass per unit length, mass moment of inertia per unit length will come. So it is the equation of C. Rest of the discussion are same. Here, if you write the equation of theta, it is like this: A sin omega by C x plus B cos omega by C x, capital C sin omega t, capital D cos omega t. Okay, same table will come. I am just copying this now. Okay, if it is free, only difference is instead of x it will come instead of y variable is theta na. So can I say at x equal to 0 in fixed theta is 0, at x equal to L also theta will be 0, but frequency equation is again in terms of sign. So omega L by B C will be n pi, n will start from 1, because by putting n equal to 0 omega equal to coming 0, which is not practically possible. Frequency of fundamental mode, put n equal to 1, which is first non-zero frequency, which will be pi C by L. If it is fixed free, at x equal to 0 it is fixed, so theta will be 0. At x equal to L it is free, so del theta by del x will be 0. Frequency equation in terms of cos, so omega L by C 2n plus 1 pi by 2, and is starting from 0. If you put n equal to 0, it is coming non-zero, which is frequency of fundamental mode. It will come pi by 2 into C by L. You can do calculation. If it is free, so means at x equal to 0, del theta by del x 0. At x equal to L also, del theta by del x 0. It will come in terms of sign, means omega L by C n pi, but here n will start from 0, because if we put n equal to 0, omega will be 0, but that is rigid mode, which is possible. So here omega 0 is also possible. But if exam asking fundamental frequency, means first non-zero frequency, which I will get by putting n equal to 1, it will come pi C by L. That's it. So same discussion is repeating. Okay. I am discussing some questions related to transverse vibration of string, longitudinal vibration of bar, and torsional vibration of shaft. Okay, what this question is saying? What is the ratio of fundamental frequency during longitudinal vibration of shaft? It is shaft written, but actually you can write this as bar, but read this. Whether it is bar, beam or shaft, till see whether it is longitudinal vibration or torsional vibration or transverse. So it is longitudinal vibration, means it is like longitudinal vibration of bar. When both end is fixed to the when both end are free. So see, when both end are fixed na, okay, in that case what will be the frequency of fundamental mode? So in this case fundamental frequency is sin omega L by C equal to 0, means omega L by C equal to n pi. Now frequency of fundamental mode, suppose this case I am referring as case 1. So suppose frequency of fundamental mode I am referring as omega f1, f for fundamental mode, 1 for case 1. So first non-zero frequency, here n is starting from 1. Yes. So we will put n equal to 0, 1. It will be omega L by C equal to pi. So omega will be pi C by L. Equation 1. Now second case is free. In free also again frequency equation is in terms of sign. So omega L by C will be again be n pi, but here n is starting from 0. But examiner is not asking frequency by putting n equal to 0. Examiner is saying calculate frequency of fundamental. Fundamental, suppose this case is case 2. Fundamental, here 2 is not representing frequency which I am getting by putting n equal to, no. 2 is for case 2 na. F is fundamental frequency, means first non-zero frequency. So if we put n equal to 0, it is coming 0. So that is not fundamental frequency. Now put n equal to 1, it will come non-zero. So that is fundamental frequency, and by putting n equal to 1, it is coming pi C by L. So both are same. They will take their ratio 1 divided by 2. It is coming 1. So we are asking ratio of fundamental frequency in these two cases. It is coming 1. So this is the answer for this question. Like this you can solve. Okay. Like I am discussing this question. What this question is asking. Again, the ratio of fundamental frequency in torsional vibration in shaft when both ends are fixed to the when one end fixed, other end fixed. So suppose in case 1 I am taking both ends fixed. So in case frequency equation is sine omega L by C equal to 0. So omega L by C n pi, n is starting from 1. Now frequency of fundamental mode for case 1 means first non-zero frequency, put n equal to 1, I will get it is coming pi C by L. Okay. Now in case 2 I am taking one end fixed, other end free. In fixed free connection, frequency equation is coming in terms of cos. It is cos omega L by C, which is 0. Okay. Now it omega L by C will be 2n plus 1 pi by 2. Here n is starting from 0 na. Now fundamental frequency means first non-zero frequency. So first put n equal to 0, see whether it is coming non-zero or not. So here by putting n equal to 0, it is coming non-zero. So it is fundamental frequency. And by putting n equal to 0 here, pi by 2 will remain. So it will come pi by 2 into C by L. Now suppose this is equation 1. This is equation 2. So examiner is asking omega F1 divided by omega F2. How much it is coming? Pi C by L is common. So that common part will get cancelled. So here 1 will remain, divide by. Here 1 by 2 will remain. This 2 will go above side. So it is coming 2. Okay. So here the ratio of fundamental frequency in first case, that is when both end is fixed, to the second case when one end is fixed, other end is free, is coming 2. Very simple question. So for this question, the correct answer is 2. Yes. Now this is the question. The partial differential equation in torsional vibration of a shaft is given like this. In this equation, what is GJ? Torsion rigidity. What is I? It is mass moment of inertia per unit length, not total mass inertia. It is mass inertia per unit length. Okay. You will see that equation is same which I had discussed, because I was writing the equation like this: del square theta by del x square equal to 1 upon c square del square theta by del t square, where c was root over gj by I. So same equation is coming na, because it will shift this gj this side, here I upon gj will come. I upon gj in times del square theta by del square theta by del t square side, and in del square theta by del t square side I am writing 1 upon c square. She will do equate this now. From this you will calculate c, again same is coming, root gj by I. So that equation is not different. That is same which I discussed earlier. Okay. Because sometimes if examiner asking frequency, now you need to find the expression of c, because I am writing frequency equation in terms of c. So c is root gj by I. Same expression. Okay. But here examiner is asking simply boundary conditions. One end of the shaft is fixed. Both end of the shaft is fixed. What will be the boundary condition? Diagram should be given, but if not given, draw the diagram like this and take x from this location. From one end. So see, both end is fixed means at x equal to 0, theta equal will 0, and at x equal to L, theta will be 0. So it's not correct, na? Yes, this is correct. X equal to 0, theta 0, x equal to L, theta 0. So B is correct. Okay. So for this question, the correct answer is option B. Second, now if this is the repetition question, it is common data question. Okay, actually this question has come in GATE examination. Now same data is valid for second question also. Now for this, if the nth mode frequency of above shaft is given as nth mode shape is given as sin n pi x by L, then the nth natural frequency of the shaft will be. Okay. See, if we put in the equation of theta na, what I am trying to say. See, simply examiner asking nth natural frequency. Here, both end of the shaft is fixed, means it is fixed connection. And we know for fixed connection, the fundamental frequency equation is coming like this: sine omega L by C equal to 0. Sine omega L by C equal to 0. Yes. Okay, so omega L by C will be equal to n pi. So omega will be n pi C by L. So it is the frequency of nth mode. Okay. Now n pi. Now what is the expression of C? C is root over Gj by I divided by L. So n pi root over Gj by L divided by L, matching with which option? Option A. So for this question, the correct answer is option A. Clear? Yes. Now next topic. Now we'll discuss transverse vibration of beam. So see, this topic is now here now. The differential equation which will come will come of fourth order. Just one second. Just one second. Here now, what I am trying to say, in beam, transverse vibration, if it is occurring, okay, this is a beam. Suppose the flexure rigidity of the beam is EI. What is EI? It is flexure rigidity of beam. And what is M? It is mass per unit length. M is not total mass. It is mass per unit length. Now see, here again in transverse direction, suppose displacement of the beam is Y. So again it will be function of two variables. One is X, second is time. Okay. So again here partial differential equation will come. But here partial differential equation is not a wave equation. Here partial differential equation is not a wave equation. Here if you write partial differential equation, it is like this, that you have to remember. Sometime examiner can ask del to the power 4y del x to the power 4 plus 1 upon c square del square y by del t square equal to 0. So that you have to remember. Why, sir? One second. Okay. Why, sir? Because this equation is different. So the discussion of transverse vibration of beam is entirely different. Okay. Here the formula to calculate C is now root EI by M, where EI is flexure rigidity, M is mass per unit length. Here in EI, I is not mass moment inertia. It is area moment of inertia of the cross section about neutral axis. Like if cross section is circular of diameter d, I will be pi by 64 d to the power 4. So this is the equation. Now here if you write the solution now, in solution it is del x to the power 4. So in solution 6 arbitrary constant will come. 4 for this, 2 for this. So here now equation of final equation of y will be like this: a sine beta x. What is the expression of beta? That I will discuss, don't worry. Plus b cos beta x plus c sine hyperbolic beta x plus d cos hyperbolic beta x. So here if you solve the solution now, it will come like this. It is as a function of x. Then function of time, a b c d I use now e sine omega t plus d cos omega t. So again the frequency is omega. Okay. Now solving this equation is now very lengthy. So very rare question will come in which examiner will ask to solve this question, and by solving this equation find the natural frequency. Here if question will come now, either examiner will ask just the boundary condition, and I will write the boundary condition for various cases, don't worry. Okay. Second, if question is coming, sometime examiner will directly give the frequency equation, and if frequency is given, equation is given, you can directly calculate the frequency. But examiner will never ask the question regarding finding the solution of this equation, because that is very lengthy. But here question can come regarding boundary condition. Here how many boundary condition are coming? So in space coordinate, you can see 4 arbitrary constant are coming. So here I require 4 boundary condition, which depends upon end condition, na? And definitely 2 initial condition. Okay. Now see, this boundary condition mainly depends upon the support system. So see, if it is a fixed beam, because now here na support, various type of support is also important, whether it is fixed support, whether it is hinge or roller support. So see, here I am writing boundary condition, na? Okay, 4 boundary condition, but we okay. Before that, one more important equation. What is beta here? Here beta in a, you remember like this, beta to the power 4 is omega square by c square. Okay, so beta to the power 4, if you know beta, you can calculate omega also. Now, first I am writing boundary condition for fixed beam. Fixed beam means both end is fixed. You have studied these things in strength of material also, na? Length of the beam is L. Now, here now 2 things is important. One is deflection and second is angle of slope of deflection curve. So see, if any end is fixed, at that end deflection will also be 0, and can I say angle of slope of deflection curve will also be 0, because it cannot rotate also, na, fixed end. So can I say, if the support, that I will write separately also, if support is fixed, na, at fixed support, here I am writing in box, at fixed support y will also be 0 and del y by del x will also be 0. That I am not discussing for string or longitudinal vibration of bar or torso vibration of shaft. This I am discussing in beam, when in beam transverse vibration is occurring. So in that case, if any end is fixed, because at fixed support, neither it will allow vertical deflection nor it will allow rotation. So slope of deflection curve will also be 0. So here, can I say at x equal to 0, y will be 0. At x equal to 0, del y by del x is also 0. Similarly, at x equal to L also it is fixed. So at x equal to L, y is 0. At x equal to L, del y by del x is also 0. These are the 4 boundary conditions. Okay. Next, if it is cantilever beam, cantilever beam means one end is fixed, other end is free. Right now, suppose I am taking x from fixed end. Now, here, this I already discussed. Now, at fixed end, deflection and angle of slope of deflection curve will be 0. So, right now, at x equal to 0, it is fixed. So, at x equal to 0, y will be 0. At x equal to 0, since it is fixed, so angle of slope is 0. So, del y by del x will be 0. Now, what are the important information for free end? So see, here what conclusion you can make? Can I say if bending moment at any point is 0, then at that point del square y by del x square will be 0. And if shear force is 0, at that point del cube y by del x cube will be 0. Why sir? Why sir? Why sir? So see, this I am explaining only for understanding, but at class you have to remember this, na? See, we know EI del is actually it is d square y by dx square, but I am writing in case of partial differentiation, you can write in terms of del also. D square y by dx square is mx. So can I say if at any end mx is 0, means d square y by dx square is 0? Yes. Next, if I will differentiate this with respect to x, it will be EI d cube y by dx cube. Then it will become dmx by dx. Dmx by dx is nothing but slope of bending moment diagram, and slope of bending moment diagram is shear force. So can I say if shear force is 0, then d cube y by dx cube will be 0. That is very important. Okay. Now can I say at cantilever beam, one end is free, and you can remember at free end, shear force and bending moment will be 0. At free end, shear force and bending moment will be 0. Okay. Because no separate load is acting here, na. So we will calculate shear because only mass is distributed. So what will be shear force at this end? 0. What will be bending moment at this end? It will be 0. Now shear force 0 means d cube y by dx cube 0. Bending moment 0 means d square y by dx square 0. So can I say whenever it is free end, at free end first I am writing bending moment 0 means d square y by dx square 0. Shear force 0 means cube d cube y by dx cube 0. Okay. So now what will be the boundary condition at free end means at x equal to L. At free end both shear force 0 and bending moment is 0. Bending moment 0 means del square. Here I am writing in terms of del na. Del square y by del x square 0. At x equal to L shear force is 0. That's why del cube y by del x cube 0. This is the important. Okay. Similarly, if it is simply supported beam, means it is having hinge or roller support. Suppose I am taking it from there. So see, first of all, I am writing directly here. Hinge or roller support in case of transverse loading, it acts same, na? So say, whether at hinge support, vertical deflection will be 0. But here rotation can occur, so slope of deflection curve is not 0. So at hinge support, y will be 0. But del y by del x is not 0. But what is the one more boundary condition? At hinge support, see, at hinge support, force reaction can come, but no couple reaction will come. Since no couple reaction is coming, so at this point, now if you will calculate bending moment, it will be 0. But if you will calculate shear force, it is not 0. Because if concentrated force is coming now, so here shear force will also come. Okay. But since no couple reaction is coming, so at hinge or roller support, if it is coming at the end, bending moment will be 0. And bending moment is 0 means del square y by del x square is 0. Okay, so can I say at hinge support, if you will put x equal to 0, y will be 0, but del y by del x is not 0. But here del cube y by, del square y by del x square is 0. Reason? Because bending moment is 0. Okay, but shear force is not 0 because force reaction can come. Same is for roller support also. At x equal to L, hinge or roller support behave same na. Y will be 0 at x equal to L, but slope is not 0. But here force reaction will come, but shear force is not 0. But no couple reaction, that's why bending moment 0. Bending moment is 0 means del square y by del x square is 0. So these are the 4 boundary conditions. Okay, clear? So you sometime question will come in which examiner will ask this boundary condition. Okay. Like first I am solving this question because here I am asking boundary condition. These are the partial difference. Here instead of W, Y I am representing deflection as W, na? That is just the notation. EI is flexure rigidity, M is mass per unit length. Okay. So how many boundary conditions are required? Definitely 4 boundary conditions, and I require 2 initial condition. Initial means condition related to time. So here I require 2 boundary condition, 2 initial condition. 4, option D is correct. But what are those 4 boundary conditions? They are linked question. So at x equal to 0, it is fixed. And fixed means at x equal to 0, can I say here deflection I am denoting as W, na? So W will be 0 and del W by del x will be 0 because slope is 0. At x equal to L, it is free. Free means here no force and couple reaction means shear force and bending moment is 0. Bending moment is 0 means at x equal to L, del square W by del x square will be 0. And shear force is 0 means del cube by W by del x cube will be 0. So at x equal to 0, W is 0, A is correct. Examiner is asking which cannot miss. You have to find incorrect option. Actually, it is typing error, I think. It is del square W, del cube W, del x cube at x equal to L is 0. Okay. So del cube W by del x cube at x equal to L is 0. That is also correct. We have to find incorrect. Del square W at del x square at x equal to 0 is 0. It is incorrect, na? So C is not boundary condition. Del square W by del x square at x equal to L is 0. That is correct. So for this question, since C is not true and exam asking which is not true, that's why option C is correct. Okay. Yes. Now the number of natural frequency for an elastic beam with cantilever boundary condition is infinite. If simply a beam is given, we will assume the beam is having some inertia, so it will have infinite degree of freedom. Next, last this question. The equation of vibration is given like this. Okay. Rho A is mass per unit length, which I was denoting as m na. EI is flexure rigidity. The beam is simply supported at the end. And here frequency of fundamental mode is given like this. Then see, if you see the equation of y as a function of x, okay, so it was like a sine beta x, b cos beta x, a c sine hyperbolic beta x, a d cos hyperbolic beta x. So here in that part now, by using boundary condition, only this part is coming, means sine beta x part is coming. Okay, so just equate this with na sine beta x because it is coming in that term. So we'll equate this sine pi x by L as a sine beta x. Sine beta x. So can I say the expression of beta is pi by L? The expression of beta is pi by L. Now we know beta to the power 4 is omega square upon c square. Okay. So can I say square this beta to the power 4, or you can also say beta square is omega by c. Okay. So you will square this beta square, which is pi square upon L square, and beta square is omega by c. So it is omega by c equal to pi square upon L square. So what will be the frequency? Omega. It will be pi square c upon L square. Pi square c upon L square. This is omega equation. Now the formula of C. Okay. Now the formula of C. So C is pi square c upon L square. The formula to calculate C is, it is root over EI by rho A. So it is pi square root over EI by rho A upon L square. Now see, matching with which option? Pi square. Now you will see now, this L examiner has bring inside root. So we'll bring this L square inside root. It will be pi square root over EI upon rho A L to the power 4. It will become, it is coming root EI upon rho L to the power 4 into pi square. So matching with which option? Option B. So this B is correct answer. How I solved this question? This frequency of fundamental mode, actually it is na equation of y as a function of x. Time term is not given. So only sine x beta x term is coming. So if I will equate this with sine beta x, I got the expression of beta, and we know beta to the power 4 is omega square by c square. I had done that replacement. Then c is root over EI by m. M is rho A, na, mass per unit length. I have used that part, and I have find the equation of omega. I got this. Okay. So in transverse vibration of beam, if question will come, it will come like this. That's all. So today we have discussed the introduction of continuous vibration. Then we have discussed continuous vibration of a string, longitudinal vibration of bar, and torsional vibration of shaft first. They are analogous to each other. Separately, I have discussed the transverse vibration of beam. Okay, that's it. So we, in this series, I had tried to cover all the topics of vibration in a summarized manner. But you will refer all the lectures and you will solve the PYQ now. You will be able to solve most of the questions which will come in GATE Aerospace. Okay, ending the class now.